Today we'll be discussing about the Boolean algebra. So the Boolean algebra was named in honor for George Boole, okay, in which he investigates the uh, about the probabilities and logicates probabilities and logic thinking, and he also published the paper named as the an investigation of the laws of thought in 1854, that is the mathematical theories of logics and probabilities are being founded. So technically he's the founder of the logic theories, mathematical theories in logic. Okay, so for Boolean algebra we'll be using the binary logic. Okay, it means that if in binary logic we'll be using two discrete variable values for a variable only, that is either 1 or 0. Okay, either logic high or logic low. Okay, and then what is a Boolean algebra? So the Boolean algebra describes describes the relationship between a logic circuits inputs and outputs. Okay. As an algebraic equation. Okay. So that is your Boolean algebra. So it is being used to simplify the digital circuits into Boolean expression so that the circuit can be built with fewer logic gates and connections. So we should be able to review what is a variable, what is a complement, and what is a literal. So we have variable. So ang variable natin, that can be x, y, z, a, b, c, and so on. And yung complement natin para sa binary logic, that is complement of 1 is 0 and complement of 0 is 1. And then we have a term also called a literal. Okay, literal. So it is variable, okay, either complemented or uncomplemented. Okay, so if we have, for example, we have a function of f. We have f of, for example, we have a not b plus b, then not a. We can say this has a four laterals. Okay. Okay, so technically per character is considered as one literal. Then we perform a different operations from the previous video of the digital logic gates. We doing AND, which is similar to a multiplication, and we are also having an OR gate operations, which is similar to our addition. So your Boolean function or your Boolean algebra is very similar to our algebra, but at some exemptions that because the number or the variable here can either have 1 or 0 only. So we go to some postulates of our Boolean algebra. So these are the important notes you need to understand or to memorize or to be familiar with so that you can simplify the Boolean expressions given by a certain type of circuits or logic circuits. Okay, so first we have the identity. Okay, so that is postulates. I will be writing here postulates. Okay, so the list of postulates we used in the Boolean algebra. Okay, number one, we have the identity. Okay, identity. Okay, so that is if we have a variable x added by a certain zero, so that is always x same as your algebra. And if we have x by 1 and 1, then it can be written also as x. Okay, and then we have also a commutative law, which says that if we have x plus another variable y, then we can say that it is equal to the y plus x. Okay. Also same for your multiplication or your AND gate. Okay, that is xy that is equals to y x. And then we have also a distributive. So we have, for example, we have x then y plus z. Then we can say this one as xy plus xz. Okay, so if we have, for example, x plus y, and then we have z plus w, then you can perform the same on your algebra as distributive. So we can say this one as x, then z plus w plus y, then z plus w. Okay, you can further simplify this one as x z plus xw plus yz plus yw. Okay, so that is the same ng ating multiplication sa algebra. Then we have a complement. Okay, we have a complement. For example, we have x, then plus its complement is always 1. Okay, eh, di ba kung ang x natin ay 1, for example, ang x natin ay 1, and then we have, so edi syempre yung complement ng 1 is 0, so that is equals to 1. But if yung x mo ay 0, so meaning its complement niya ay 1, so sagot mo ay laging 1. That's why the complement identity for this postulate is that a variable added by its complement is the result is always 1. Okay. And then we have also for the its multiplication, if x is multiplied to its complement is equals always to 0. Why? Because if this is 1, then its complement is 0, then you have 0. And then if x is equals to 0, then its complement is 1, that becomes 0 again. Okay, that's why x, the product of 2 of the product of x and its complement is always a 0. Okay, and then we have also the idempotency, idempotency postulate. It says that our x plus another, the same x, would also always result to x. So take note that if we have 0, then 0, then the result will be always 0. So that's why you can say it is also equals to x. If that x becomes 1, we know that in Boolean algebra, we'll be using 1, then plus 1, then your result will be 1. So this one is x, this one is x, and the result is also an x. Okay. And then for the multiplication, we have x and x. Okay. So that is always also an x. It's because if 1 times 1 is equals to 1. So that is the same x. And then if you have zeros times 0, you have 0. So that's why the product of x to itself is itself. Okay. And then we have the involution. Okay, so the involution states that the the complement of a complement is the original variable. For example, we have x, then we have a complement of x, then we complemented that again, then the resulting would be the original variable x. Okay. And then we have also the associative law. Okay, so we have the, for example, we have x plus quantity y plus z. We can also say that one that is x plus y plus z. Okay, so you can freely remove, or I mean move the parentheses between the equations. And for multiplication, that is also the same. So you have, for example, you have x, y, and z. You can say that it can be written as x, y, and z, or you have some other combinations also, like you can group your this one, x and z. Okay. So you can freely move again the parentheses. And then we have the new postulate that we call that one as the De Morgan's theorem. Okay. Okay, so it says that the complement x plus y and the complement of the two variable is equal to just you remove the add sign, but you complement each character. Okay, so if you remove this one, you should be complementing each variable. So what happens is that it becomes x, then this time that is a product. Okay. Okay. So if you want to distribute that prime to each individual variable, you need to remove the positive sign to do it as multiplication. So that is the De Morgan theorem. So your De Morgan's theorem is very important in dealing with the simplification of two or more quantities in a parentheses, then you complemented it. So very useful ang ating De Morgan's doon. And then if we have x, y, and then complemented by prime, it doesn't mean na katulad sa ating algebra, you just distribute this prime. So if you want to distribute that prime, you should be not multiplying, instead you should be adding. Okay, so the result would be distribute first the prime, and then instead you should be adding. So that is the De Morgan's theorem. Okay, if you want to check 1 0 1 0, then try to substitute. For example, we have here the 1, and then meaning y cannot be x, so that's meaning it's 0. Then the result, the sum of these is that is 1. Then kung i-complement mo ang 1, that becomes 0. Okay, so what happens here kung ganito? We have x, so ang x natin 1, ko-complement mo siya 0. So ang y natin ay 0, ko-complement mo siya na 1. So that is 0 times 1 still 0. Okay. Okay, you can try also the other one if your x becomes 0 and your y becomes 1. So this term still 1, then complemented, that becomes 0. This one is x, so x complemented, 0 complemented is 1. Then yung y mo is 1, so complemented is 0. So the product of the two is still 0. Okay, so that is equal. Okay, and then we have to continue the theorems or the postulates on this uh, Boolean expression. We have the adsorption. absorption postulate. It says that x plus xy becomes x. Okay. So how do we do this? How did we arrive? It's because you can factor x, then 1 plus y. Okay. Then whatever the value of y here, it can be 0, it can be 1. So whatever the values of y added by 1, the result is always 1. So that's why we can simplify this one as 1. That's why the remaining term is x. So that's why it's an x. For multiplication, that is also very similar. Like we have x, then quantity, then x plus y is equals to x. Okay, so if you want to perform this one by distribution, you get x and then x, then plus xy, okay, equals to x. Okay, then you perform this one. So x multiply to that the same variable. Kumbaga meron kang 1, then multiply mo agad sa 1, result mo 1. Hindi parang x lang. And then if you are x is 0, then 0 din yung isa, multiply mo 0 din. So parang naging result is isang x lang, sir. I could simplify this one as x only. That's okay. Then if this is x only, then I could factor out my x and then I could write this one as x plus x. Okay, so this one, automatic 1. So this becomes x equals to x. Okay. So if you can really see that the other theorems or postulates is just uh, the derivatives, or I mean nanganak lang siya dun sa mga nasa taas nating mga postulates. So we try to raise this one, then we add another postulate which is called as the consensus. It says that your x, y, then plus x prime z, and then plus y z. And then you can actually factor out the z, and then what about the others? So you can factor out. Okay, you can factor out this x, or you can factor the z. Okay, okay, let's do this one if we want to factor y. Okay, so that is x, then that is y, and then plus y, and then this becomes ano titira, that is x prime and z. Tamaga. Okay. Oh, sorry, that is I'll be factoring the y, right? So I'll be factoring the y, or I can say that yes, I am supposed to factor y. Okay, okay, this one. So the result would be a y, then x plus z, and then that is plus x prime z. Okay, so there's nothing you can simplify of. Okay, okay, let's bring it down. On this expansion, we can say that we cannot simplify this one easily without changing here, okay, without changing here in terms of x also. So we try to write if xy, then plus x and say x naught, and then say plus yz. So, di ba class ang yz natin, pwede nating sabihin na yan ay yz times 1, right? Then we can rewrite this one as xy plus not z plus, I could say this one is yz, that is x plus x naught, right? Try to check this one because the a variable added by its complement always result to a 1. So that is okay. So I am doing this one. It's because I am targeting to factor out all x from the together with the all literals. So distribute, say, then plus y yz x, and then plus x prime y and z. Okay, now we go to factor out all terms containing x and x prime, right? Okay, we try x here, then we have x here. Okay, so that is x. Then we have y, y, and then plus y z. Okay, plus then x primes. Okay, so this one is z plus y z. Okay, this is prime, right? Okay, so inner side we can also factor out y. That becomes 1 plus z. Then this one, okay, my bad. Okay, plus that is x prime, and the other side we can also factor out here. So we can factor out z. Okay, so we have z, that is 1 plus y. Okay. We know that any y, any values of y will result always to 1, right? This one is always 1 also. So that remains to the x. Then we have xy plus x prime z, right? Okay, so that leaves us to the final answer. Okay, so we reduce the literals from 6 to 4 only. Okay, if you could notice, this one, parang ito class ay sumobra lang. So, minsan, kaya ang tawag natin sa consensus ay redundancy. Okay. Okay, so that's why ito yung ginawa natin. So, we can say this one as xy plus x prime, say. So, I rewrite this, I rewrite this, into its theorem. Okay. Okay. Then, ayaw madala. Okay, so this one is, ito natin. Okay. So this becomes x, y, then plus x prime z. Okay, so that is the simplification for the consensus. And for the, like this one, for the multiplication, if we have x plus y, and then times x prime plus z, and then another y plus z, and then the result would be drop here. Okay, so drop nyo na to class kasi magiging redundant lang siya. Yung derivation niya would be, yung proof niya class the same nung kinuha natin to. Okay. So we have the answer here that it is x plus y, and then x naught plus z. So that is the another theorem. And then we have a theorem called simplification. So what is simplification? We have x plus x naught and then y. It becomes only, okay, so it becomes only x plus y. Okay. Why? Bakit class? Kasi kung mapapansin nyo, di ba kung x and y lang, di ba 1 and 0 lang. Meaning kung si x mo class 1, ito ay 0. Meaning si y mo is 0 din. Kasi hindi pwedeng maging 1 yan. Kasi kung 1 yan, magiging x yan class. Meaning, yung x not mo class, you can also rewrite that one as y, right? We know that y multiply to y is just y. That's why, ganyan naging ano niya, concept niya. Ito lang, parang simplification niya, it becomes na ang x plus ang x prime mo, di ba parang, sir, kinomplement ko yung x, edi parang y din siya kasi yung y mo is not x. Kung 1 ang x mo, then 0 ang y mo. Or yung y mo, parang ginawa mo, kinomplement mo lang yung x. Okay, so the result would be like this one, y. Then, di ba ang product nila is always yield to a single variable lang based sa postulates na na-mention natin sa taas. So that's why it's a result of x plus y. Okay, so we try to have an example of simplification. Okay, okay we simplify. Okay, letter A, simplify AB plus BC and then B plus C. Okay, so to simplify, we will be reducing the literals from 1, 2, 3, 4, 5, 6. So it has 6 literals. Okay, and then we go to distribute this one. Okay, so AB plus that is B, then BC, then plus BCC. Okay, we know that this one becomes B only, right? And then becomes C because 1 times 1 is 1 and 0 by 0 is 1. Kung the same ang variable class na tinanong sa sarili niya, would result to that variable again. And so you have the result here that AB plus B and plus C. Then you can factor out B here. So that is B, then that is A plus 1, then plus C, right? Okay, and then how, let's review. Okay, so I forgot. There's thing I forgot. Okay, here, here. This is AB. Okay, so we ignored the C. Okay, so that is plus BC. And then this becomes C also plus BC, right? Okay, this one. Now what happens is that BC plus BC is always BC, right? Parang ginawa nyo x plus x, that is 1 plus 1, di ba x pa din? Kung yan ay 0 plus 0, di ba yan ay 0 pa din? So that is the same x. Okay, so what are you going to do is same lang nito. Ito, compress siya sa BC. So this becomes AB plus BC. Okay. Then you can factor out your B, then A plus B, A plus C. Okay, so that would be your answer, simplified. Okay, so now you have 6 literals down to 3 literals only. Okay, let's try another example. Okay, letter B. Okay, how about we have A plus B, and then that is quantity A plus C, and then plus AC. Okay, so what would be the simplified Boolean expression for this one? We go A, then distribute, that is AB, and then plus BC, then plus AC. Okay, so let's go to try to factor out if we can have A here, A and A. Then we can also factor B. So what if factor ko to at ito? Okay, so we have A, that is 1 plus C, and then plus ito, factor ko yung B, that is A plus C. Okay, so what happens here, this becomes 1. So you have result of A plus, sige, distribute ko ulit class AB plus BC. Okay. Then, factor out ko ulit ang ano. Pwede ba kung ma-factor out ito na lang in terms of A? A, that is 1 plus B, then plus BC. Okay. Then we know this one again is 1. So my answer would be A plus BC. So wala na reduction. Okay, so that is your answer. So that is 1, 2, 3, 4, 5, 6 literals down to 3 again. Okay, let's try to have another example. Last example, letter C. We have, let's try terms we have involving inverses, that is x, then y not plus z, and then quantity x plus y, then not, and then multiply again to z. So what are we going to do? You do the multiplication. So one by one, this is x, and then y prime. And then this one is plus x, then that is y prime, y prime. This one, that's become plus xz, and this one becomes z plus y prime z. Okay, multiply to z. Meron kasi sa labas. Okay, we can reduce this one. Okay, ano to? That is always x, right? And this one is always y prime. Okay, then let's rewrite our equation. That is xy prime, and then plus xy prime plus xz plus y prime c, and then multiply to z. Now the other thing is that this one, okay, so that is very the same. It's like you are saying that a plus a, right? So that is becomes a also. So this becomes xy prime plus xz plus yc prime, y prime, and then z. Okay. So next, what would be the resulting? So let's try to distribute this as z, xy prime z plus xz z plus y prime z and z. Okay, we know that this is just the same as z. So that is xy prime z plus xz, and this is plus zy. Okay, now what terms can we factor out? Mhm. Okay, we can factor out where? Z. We can factor out Z. Where? Here. Ito. Factoran kaya natin to. Ito. Lahat. Okay, that is Z. That is XY. XY prime and wala na say plus X tapos plus Y. Right? Okay, so again, we can factor out here the X. So say that is factor out ang X, then Y prime plus 1, then plus Y. Okay, we know this is always 1, right? And then so that's our equations can be simplified as Z plus X plus Y. Okay, okay. Okay, let's try to review. Okay, Y prime, Y prime. Okay, we forget this is y prime, right? Because here y prime, then y prime, then this is y prime. Okay, then this is y prime. Okay, so that is your answer. Okay, that's all for your Boolean algebra simplification.